Hello folks, my name's Ed Overstreet and welcome to the Night Sky Imaging YouTube channel. Last night we gave it a go and the sky just was overtaken by clouds. I did get some imaging done on Jupiter and Saturn, but it was a fight that I wasn't going to win, so I threw in the towel. And hopefully tonight will be a little better. There are clouds about, but it looks much better tonight than it did last night, so maybe they'll go away. But at any rate, I am again out with two telescope kits. I'll share that with you. And those are we have the Smith-Cassegrain that's going to be doing some planetary imaging. That's a Edge by Celestron, and an 8-inch. And this is a Stellar View 70T, and that's 330 millimeter, and that's wide field. This is Jupiter. It's very low in the sky. Saturn's right above it, out of the picture. But Jupiter is extremely bright right now, so maybe that's a good sign that the clouds are staying away from that neck of the woods. So sometime around 9:45 I'm going to fire up this telescope and set up an imaging sequence on Andromeda. I will be using Sequence Generator Pro, and I have my target set up. My plan's going to involve 4 hours and 25 minutes of imaging time. You have to factor in time for dithering and time for focusing, because we focus on filter changes, and I focus each time the temperature changes 2 degrees either way. I'm going to start off with taking 30-second exposures using a luminosity filter. This is a clear filter, and I'm going to take 80 of those images. We can go ahead and come back here, and then we're going to take 80 red filtered images, and those are going to be 45 seconds. The red and the green and the blue will allow less light to enter the camera and strike the sensor, so I can get by with shorter exposures on the lume filter. The lume filter does have, though, a UV IR cut filter applied, so it's more than just a luminosity filter. The green, blues are both 45 seconds. I hope to get 80 of all of these. And then I'll end the night taking hydrogen alpha. Andromeda has a considerable hydrogen alpha presence throughout the galaxy. And those are narrowband filter. A lot less light will pass through. So I'll be taking 3-minute exposures, and I'm hope to get 15 of those. So when the night is over, I will have somewhere in the neighborhood of 300 and let's see, that's 335 images, and that should be a gracious plenty to pull out a nice capture of Andromeda. So that's the plan, and it's not at a good place in the sky right now. It's extremely low. It's probably around 22, 23 degrees now, and just because the clouds are allowing me to get started kind of early, I normally don't like to start on a target that low in the sky, but right now this is the location of Andromeda, and that's 22 degrees. So she's around 22 degrees, and when it gets to about 30, somewhere right here, which is 10:07, probably start just slightly before 10 o'clock, and that's 45 minutes, 50 minutes, 48 minutes from now. So we got a little wait. I already started cooling the camera, and I'm only going to cool to minus 15 degrees below ambient. That'll be fine. I wish it could be cooler, but we really do have a cooler night for a change. So let's go back over to our planet camera and software. And the plan now is to let's go ahead and head over to find our planetary software. We have connected. I went to telescope and I clicked on connect the telescope. So the telescope is connected to this software. This is I love this Carta de Sol software. It is it doesn't take up a lot of memory on your laptop, and but it really is a dependable software, rarely crashes, and free. But I love it, and I have it on all my laptops. But we're going to go over here to Saturn, which is slightly above Jupiter, and we're going to see if we can't head in that direction. So I'm going to double click on it. I've also typed in the target, and I'm going to go up here and click on Slew To Target. So there goes the camera. We can go outside and watch this take place, and as you can see, the mount is headed in that direction. Again, Saturn is off in this neck of the woods where you can't see it, and Jupiter's just about ready to rise out of the frame, and I would say that's probably about 20 degrees altitude. So let's go back in and head over to I'll use this wide field guide camera as my finder scope, and what I'll do is I'll take this and nurse my mount along until I get I'm surprised Jupiter's not in the frame. So let me bring just 1 second. I'm closing some windows that you can't see, and but I'm going to bring nudge the mount over and bring our Jupiter into the picture. I want to change the speed to 2 times sidereal, and let's try moving east. I recognize this star, and I think it's right behind it. Here we go. And let me go up here and grab the bullseye, because I'm going to use that to center view and bullseye. So let's continue. Let's speed it up again. This is 3 times sidereal. And now we can slow it down to sidereal, and my outside camera has sound. Okay, now let's see if that happens to be in my software's field of view. There she blows. So we have also a way of centering this. So let's get a single crosshair, and let's move this east a little more. Right there, and then let's move it north. Went too far. Let's come back west. Okay, and maybe south a tad. And then let's go back west. It's drifting on me a little bit here. And let's go down to PhD 2 and let's start looping. Looping is taking a series of pictures, and let's speed up to about 2 seconds pictures, and then let's start guiding. It wants me to build a dark library, and I'll need to do that again, but we are now currently guiding, and that kind of help keep Jupiter centered throughout the night. Not Jupiter, Saturn. We will be going over and imaging Jupiter in just a minute, or actually it's going to be a few minutes. So let's come back out here, and I don't want to use that region of interest. Let's come down to about here. Actually, let's go to, I guess that's where we already are. Let's go 488 by 488, and I'm going to position that right in the center. I'm going to lower the exposure just a little bit, even a little more than that, and speed up the frame rate some. And let's go up and start a series of captures. I want to take 4-minute captures, and I want let's take 20 of them, and between pictures let's make it a 10-minute interval break. And so let's go ahead and start this. So 4 minutes times 20, that'll be an hour and 10 minutes of continuous imaging of Saturn. One 4-minute AVI file after another with a 10-second pause between the two. So there will be almost a half a minute of pauses, 20 seconds of pauses as we go through this. So we're going to have a pretty lengthy imaging time, and with that we can kind of go on over now and check on the other kit. By the way, this is another laptop that it's not outside, it's actually right behind me. Unfortunately, I use Apple products. This is an iMac that I'm on in my home, and kind of converted our bonus room into my observatory, and my kits are outside and I stay inside most of the time. I do some outside imaging, but most of the time I like to stay inside, away from mosquitoes and heat, humidity, and cold. And so I watch television and image and drink coffee and put my feet up and relax. But I do have a Mac, and all the software that I use, Autostakkert, Registax, IMPPG, PIP, WinJuPost, all of that is made for Windows only. So I have Windows laptops, and so I have the Windows operating system, and kind of grew up on DOS and then Windows, so I'm familiar with it. But I have a third computer behind me, and that computer is used for my solar kit. And but I have WinJuPost pulled up, and when you have WinJuPost, I go to the Ephemerides, and if you'll click on graphics and then use texturing, then you'll get a picture of what Jupiter is going to show you if you click on real time. Right now it's the 4th of September, and universal time it's 1:23, which is actually 9:23 Eastern Standard Time. We're 4 hours different. But if you want to know what's up against with Jupiter, you can start advancing. Click on this, and you can see one of the moons going around Jupiter. And here comes the great red spot, and that's going to be at 7:03 UTC, which is 3:03 in the morning. I can tell you where I'm going to be at 3:03 on the 5th, and it isn't going to be here. But some of my Roper Mountain friends, Josh Palmer, he will probably be up most of the night. He is a master at imaging planets. His results are the bar that we are trying to reach in our astronomy organization, but my goodness, he's good at it. At any rate, if we were staying up, we would be able to catch the great red spot. And let's see if there's any moons going to what's cool is when you can get the great red spot and a moon at the same time associated. You know, you can see the shadow, you can see the moon and the shadow on the surface of the planet. So anyway, we're going to head over to this system. We've hit the cooling. The one thing that I can do right now, we can go ahead and put this to sleep, but the one thing that I can do while I'm waiting for 10 o'clock when I start imaging Andromeda is I can go ahead and run a focus run. So let's do that. Let's go ahead and click on run, and it's going to do an automatic focus. It's going to use the luminance filter to do that. And so I'm going to set this aside. One of the first things that happens when you do a focus run is that it will defocus your camera by a certain number of steps that you decide. Then it'll take another picture, and it will move the focus back towards where it started and take another picture. And so right now it's heading in one direction, and then it'll reach a point, then it'll start heading in the other direction, taking pictures. And there will be a point of intersection, and it's at that point of intersection where you're going to get the best half flux radius number, which is the lowest number you can possibly get, and you'll be at the best focus point. And this is done automatically for you. So right now it's saying that the position, the step position of 11,375, that if now it's 11,368, if you move the focuser stepwise to that there's a 99% quality chance that you're going to have the best focus possible. It's impossible for me, with my 76-year-old eyes, to get a focus with my eyes. You get close, but you don't get precise. And so in astrophotography, precise is critical. So at any rate, I have a half flux radius of 1.69, which is actually the seeing conditions for this kit tonight. And we can go ahead and close this out, and we have our focus finished, so we're in pretty good shape. We can take an image. Let's take a 5-second image, and there you go. And so we really are pretty finely focused. We stretch it a little bit and we can zoom a little bit, and you see how noisy everything is. But those are sharp stars, sharp round stars. I am undersampled, and I have to fix that when I go into post-processing. When you're undersampled, your pixels are actually too big for the small stars, and they get real blocky looking because your pixels are square, and so you have to drizzle, and an algorithm will manage that in such a way it's brilliant that your stars will become as you would want them if you had the right telescope camera combination, which I don't. Okay, let's go back over to our planet, and Saturn is behaving itself, and we are still capturing frames at the rate of 34 frames per second, which is very slow. But Saturn is a very dim planet when compared to Jupiter. I can image Jupiter at 80, 90, and 100 frames per second because of its brightness, but I can't get by with that on Saturn. So while we're waiting, I tell you what we can do. Let's bring up Autostakkert, and let's open up one of these images that we've taken. And see what they look like. We're going to go to our external solid state drive, and I need to change this date. This is we need to rename this. It's not that important. We're going to go ahead and close you out. We'll bring you back, camera. Let's rename this. Talking to myself now. 3. You don't want to name it. Come on, let's go. Cancel. Oh, I know we can't name it while I'm saving files to it. I have to do it afterwards. Alright, let's bring up the first one that we took, and there it is. We can take our hand controller and hide that, and let's kind of scrub through it. Last night these planets were bouncing all over everywhere. The scene was, it's the worst I think I've ever seen it. And it was rated on the apps that I used for let's just go there. I will use planet when I am imaging planets. I'll use surface if I'm doing the sun or the moon. I am going to use 7 for noise robust, and auto size is the only other thing I'll have checked. So I'm going to analyze this. And I'm going to save about 50% of them. Could probably get by with saving 60% of them. I am going to have replace, and I want close to edge. I don't want multi-scale. Close to edge and replace, and then I'm going to place a grid, and close to edge will cover the whole planet. And let's go ahead and stack it. Not much else to do in Autostakkert. and it'll take it a few minutes. Hear me swallowing. I go through a pot of coffee on a night like this. We're now stacking. That takes the longest. And how many frames are we stacking? We got 5,430 frames. So no, we got 8,144. We happen to be on 5,430. So we have 8,000 frames that are in this AVI file. And when it's all said and done, we're going to take all of those and we're going to compile them into one picture. Everything that we're taking tonight, we're going to compile into one Jupiter picture, a Saturn picture. I can't keep them straight. It's not like they look alike. But once it gets the stacking out of the way, then it's going to go much quicker, and then it's going to take time because it's a slow computer to start out with, and we're going to be using 60% of 8,000, so we're going to have 4,800 some odd frames are being stacked. So, but we are waiting around for Andromeda to be in an imageable position. In a few minutes, I'm going to go ahead, when we finish this, I'm going to go on over and slew to Andromeda, and I'll go ahead and start guiding, plate solve and start guiding, but I won't start imaging for a while. We're at 92% of our way through the stacking process, and the rest of it goes quicker. Nothing's quick on this machine. Okay, we can go ahead and set this aside, and let's bring up Registax. Typically, I'm going to use either castrator or pip first before I use Autostakkert to crop and center the planet. So let's open up. Let's just go to our external hard drive, and the reason why it's got 9:04 is that UTC time is already tomorrow. And so here's our first Saturn TIFF image. Don't know what happened there. Okay, now I just happen to know that I want to change the geography or the orientation of Saturn and flip it, and I'm going to change that to 100 and I think 30 degrees. Yep. And then I'm going to take the histogram and I'm going to brighten this. I'm going to move this slider over to about there. That's too much. About there. And so we add a little brightening. Then I'm going to go and color balance it. And that we've done. So now I'm going to run a saved set of wavelets, and so here's our first image of Saturn for tonight, and that's about 4,800 frames stacked. So it's I'm optics limited with an 8-inch edge. I have a 2.5 times PowerMate, Teleview PowerMate Barlow, and I have a atmospheric dispersion filter that probably needs some adjusting. But at any rate, that's what we're going to be kind of up against, and it may not get any better than that throughout the night unless our seeing conditions get really good. But I have to have near perfect seeing in order for my optics to do much better than that. And so let's close out Registax. I don't want to save this, nah. And we're still nursing Saturn along, and again that's going to run till about 10:20, and that's when I'm going to head over to Jupiter. In the meantime, I'm going to go back over to, not there, but here, and we're going to bring up our control center. And actually, let me see where I may end up landing on a house if Andromeda isn't high enough. Let's see how high it is. So right now we're at, bring this up so I can see. Right now we're at 26 degrees. That's higher than the tops of the houses, so we're good. We can rock and roll. Okay, let's go ahead and let's bring out our outside camera so we can watch. I want the outside camera. And let's log on. We did. And now let's slew to our target, and let's watch the stellar view head over towards Andromeda, which, as you're going to see, is really low in the sky. And I have no trees to worry about, and I know I'm up over the houses. You can't tell from this, but my telescopes are up on a hill. Maybe you can, because you can see how the fence goes up, and the top of my house is right there. It's only a single-story house, but at any rate, okay, let's center, and we're going to go through the process called plate solving. Plate solving involves taking a picture of the sky with my telescope and camera and comparing that picture with a catalog of images, and it's already solved. We're 25 pixels off in RA, and we're 26 pixels off in DEC. So we have centered Andromeda, and there she blows. Let's now start our guiding software. I'm going to start looping, and we found a guide scar right there, and so let's start guiding. I'm going to guide at 2.5 seconds. I should run the guiding assistant, and that would give me a couple good hints on what I should set my minimum move to for both RA and DEC, and at what exposure. But I can pretty much tell how our guiding is going to run, and you got to let it run for 5 or 10 minutes so it kind of works out its kinks, and you start getting some better results. Right now it's doing horrible. It's got an RMS of 1.42, but I am not concerned about it. It will I might, given that I have this time, if it doesn't get a lot better, I may just go run a calibration, and if I decide to do that, I'll bring up my planetarium software, and I'll swing around here to the south, and here is the meridian, and I'll pick a star like right here, which is about 0 DEC, and I'll check it, It's at 0.4 declination, so that would be a good star to slew to and run a calibration. You want to get close to the celestial equator, which is zero's declination, and around the southern meridian. And I usually go to this side of the meridian, to the west side of the meridian, so I don't have to worry about having to flip the mount, because it flips as it crosses, as it images beyond over this meridian. So I'll pick one on the west side of the meridian, around 0 dec, and then I'll calibrate on that star. And I'll pay attention to how the guiding's going. And let's see, we're down to 127 from 142. Let's clear it, start all over. Actually, with this wide field kit, you can get by with some guiding around 120. But if you're imaging with longer focal lengths, then your guiding needs to be much better. So now we're at 0.6, and we're going to be okay. It's just got to kind of work the kinks out, and it usually does. I have a pet curve that I can add, and I may go ahead and do that now. What's on my mind? So I'm going to I just passed it. Alright, I'm going to go to my folder, and where's my last pet curve I did? I've got 174 on a fair scene night. Do I have anything sooner than that? I need to create another one. So here's my pet curve, and I'm going to go on back to here, and down here you can see where I'm tracking its sidereal plus my periodic error corrector curve. So it's gotten worse with the curve, but that happens when you first apply the curve. It'll work itself out. Okay, so we're going to be okay here. I'm going to wait a little while before I start imaging, but everything is really good to go. I have the focus. I have it focused. I'm centered on my target. Here is the galaxy. We can take a longer exposure. Let's take I'm going to be taking 30-second exposure, so let's take a 30-second exposure and see what's going on. Here's one of the smaller galaxies out to the side of Andromeda. I'm going to have to go out and rotate the camera. I can tell you that I don't like the orientation. I need it to be going this way or this way, because okay, yeah, it didn't help much more. But this is the image. This is what I'll be taking. Let's change the filter to let's go to blue, and let's set it to blue. Now let's take a 45-second, because that's what I'm going to be doing. I want to make sure I'm not blowing out the core. So let's take a 45-second blue image. So for 45 seconds, my sensor's recording photons that are only blue. It's filtering out red, green, and only allowing the blue to enter. So it's really blocking green and red. See, my half flux radius has gone to 240, and when you exposed for a longer length of time, you allow more light to come in on your stars, so they do get bigger. Doesn't mean they're out of focus, but it does mean that they are bigger. So that changes your half flux. Let's zoom in a little bit, and this is the only other thing I might consider doing is cooling the camera to minus 20 degrees. And but noise is so manageable now in post-processing. So PixInsight has some great noise reduction algorithms, and then I'll end up in Photoshop CC and Topaz denoise when applied selectively can also do a great job of mitigating the noise that builds with long exposure photography. Okay, well, we are just waiting for our target to you know what, tell you what I'm going to do. I'm going to go ahead and start imaging, and the main reason is that I have no assurity that I'm going to be able to image in 30 or 40 minutes. Let me get what I can get. So I'm going to go ahead and click on Run Sequence, and automatically it will change this filter to the Loom filter, because that's what we're starting with. And it's assuming that I need to slew to the target, because when I start a sequence I have it set that way. Now it's setting the filter to Loom. It's going to go ahead and run another focus because we've had a temperature change, and also because I ask the anytime there's a filter change, I ask to refocus. My filters are not, they're astronomic filters, they're not parafocal, and so each filter has its own focus position. They're close, but they're not exact. So we're going to run this routine. While it's running this routine, let's go see how Jupiter's doing. And it's still behaving itself. Not Jupiter, Saturn. And when I start imaging Jupiter, I'm going to call it Saturn. I guess I'm old, just getting old. Yeah, it's okay. I love doing this. Now this is a live image of Saturn that we're imaging. We're taking, if you're just joining up, we're taking 20 4-minute videos at 34 frames per second. We're getting about 8,000 frames in each video, and we're pausing between videos 10 seconds. And so that's kind of what's going on here with the planet Saturn. We did process one, and it's going to be okay, not great. I do think the scene is going to get better because the planets are getting higher in the sky, and the more they move away from low atmosphere. PhD just made a correction. Anytime you see the planet jump like that when you're guiding, you can open up PhD and you can tell right here it made a correction right here. So that's what causes that. Let me tell you how sensitive these telescopes are and these mounts. And I mean sensitive. We have a neighbor that has a teenage son that has or maybe a daughter, I'm not even sure who it is, but they come in, I think, from work in the evening, at night, and they have the bass boom boom kind of on their car, and it will move my graph. And now keep in mind that my peers are buried in each peer is buried in cemented to 4 2 cubic yards, which is a lot of cement, and so they're anchored really good in the ground. But still, doesn't matter. That boom, 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 boom vibrates the telescope and the camera, and you'll see wiggles in your PhD graph. So it doesn't take much. Let's go back over and see if we've started. Whoops, I don't want to go there. We want to go here. And we've already taken 2 pictures. So this is our first one, and we're in 8 seconds. I'm down here on this bottom green bar. We have 4 seconds left in the second image, and we're downloading it. So now we have 2 images, and let's go bring our control center back, and it shows that we have 2 down and 78 to go. Then we're going to change filters. It'll do that automatically for me. It's all automated. It'll spin around to the red filter, and it will change the exposure time to 45 seconds. We'll take 80 of those. Then it'll spin to the green, then the blue, then to hydrogen alpha. Probably 5.5 hours later, I'm going to add an hour to the imaging time for dithering between images and for focus changes that will happen throughout the night. We'll know that for sure there's going to be 4 focus changes when we change these filters. But as the temperature drops, and I'll show you, let me bring up the power box, which is the control center attached to each telescope. It's the Pegasus Ultimate Power Box. And if I go over to the environmental graphs, you're going to see where the red is the temperature, and the blue is the dew point. And when the temperature and the dew point intersect, you can count on having dew accumulate on your gear. And so moisture is already landing on the grass and your equipment, and for that reason I'll keep these and by the way, this Pegasus power box, they're just awesome. It automatically turns on the dew filters for the camera, for the main scope and the guide camera, and it has them up to maximum, so there will not be any dew on my equipment because of the heat coming out of these dew heaters. And so there'll be none on my glass. Actually, it just keeps the telescopes dry. Don't ask me how. It does. Right now the temperature is 68 degrees out, and it's going to go down, I think, to 59. So we got a 10-degree swap in decline in temperature. So I have this set up to refocus every 2 degrees, so it'll focus at least 5 more times, probably throughout the night, for temperature changes. This has the power that's being used in voltage and current. Current is amperage, and I can check my USB plugins out there, the camera, the mount, the focuser, and let's see what else is out there. The dew heaters are plugged into another, but we have the guide camera, and we can also, if you want, you can use this to Pegasus can also run your focus. So, but I don't use that. So back to power. I turn on, I don't need the flat panel, it's just turned on. I can turn that off, but I'm pulling 0.78 amps on my mount. The focuser's not focusing, so I don't have anything there. The camera's pulling 0.67, and that's the fan only. The fan is cooling and keeping the temperature 15 degrees below 68.9. And that's what's happening outside. The humidity is at 99%, and so that's why we have dew, and that's why you have to have dew heaters on your gear. So, okay, we've had 8 images taken, and so we're rocking and rolling right along. And we can go back and let's head over and see what's happening with our other kit. There's Saturn, and it's behaving itself. We're capturing, let's see how many frames we've already captured. And we want to go down to the Astro. We want to go to Planetary and Saturn. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, with 10 to go. So we have 10 SIR files with 10 to go. Now, on purpose, I asked Sharpcap to save this additional information for me that I can spreadsheet, and on exposure and gain and my settings. So histogram information and all of that. I like to have that available when possible. I'm going to have to move my planet up a little bit. To bring the mount up. And I'll wait till this finishes. We have 10 more to go, and I'm going to wait till this finishes this capture, and then I'll have 10 seconds, and during that time I'll recenter this. Now, the data that I'm getting right now is not going to be really good data to work with. So Saturn kind of gets cheated because it's up first, and so I take it first, and it's low in the sky, and I end up shooting Jupiter next. And when I start shooting Jupiter is really when I should be shooting Saturn, because it's risen high enough that I should have much improved seeing. But I'll end up going and working on Jupiter. Okay, we're about 3/4 of our way. I'm looking over here at the bottom right at Sharpcap, and the time left is 1 minute and 2 seconds. Now it's 59 seconds left on this imaging run, and then I've got 10 seconds to recenter. And so with that being said, we're going to do that. Okay, recentered that, and it's a little off, but at any rate, got it done just the nick of time, and we're back to capturing. We're on our 11th SIR file, and each file is about 8,400 frames. There's going to be 20 of them, and we'll process those in PIP first, and we'll crop and center them. Then that'll make it easier for Autostakkert to stack them and make it faster. I won't debayer in PIP. It can debayer the images, but I will wait and do that in Autostakkert. You increase the file size when you debayer them, and I want to move through PIP as fast as possible. Then I go into Autostakkert, and I will batch stack them all, and then one by one Registax is where I'll apply a histogram stretch to add some brightness to the image, I'll use the auto balance, to adjust the color, auto color, and then I'll flip the mount to a better orientation, because as you can see, it's upside down now. For well, depends on how you like it or look at it. To me, it's upside down, and I like a slight angle with. You'll see. I don't like it to be perfectly horizontal. I like it to have a little bit of a tilt, not going this way, but going this way. And it's just a preference. I could go out and rotate my camera until it's exactly the way I like it, and then I wouldn't have to deal with this. Or I could buy a rotator, which costs a fortune, and that's not going to happen. But at any rate, I flip it, and those are the three things I do, and then I'll apply some pretty aggressive wavelets. No sharpening. I'll do some noise reduction, but I'll run the wavelets all the way to the far right. I got that piece of advice from watching Josh Palmer from Roper Mountain Astronomy to I just took it from him that his images look so good, so I borrowed his idea, and I really like the way that turns out. So I'm having a hard time talking, so it's about time that I say goodbye. When a little later on tonight, I'm going to go live on Facebook and YouTube, and I'm going to when I leave this and go to Jupiter, I'm going to go live, so you'll be able to find that live effort on my part on my YouTube channel. So with that being said, if you have a great weekend, and I hope everybody stays COVID free, good health, and make sure you say something nice to somebody, and you'll feel better for it, and they will too.